And you can see that we now have a nice inventory of all of these components. And this is actually a great way to do this. And I wish I would have done this previously when I've made boards. So I'll do it as well next time. Anyway, so I'd like for everybody to try to get this on their computer. But again, if not, the main point that I'm going to work on right now is just showing you, kind of going back over some of the soldering techniques that we went over last time. And that way, yeah, some of the components are different than others. So obviously there's a little bit different technique for it. So hopefully this can just help you out with it. And for those that attended last time, we did do an activity where we introduced some of the soldering to begin with. So please go back and do that activity before you start soldering on this board, just to get familiar with the soldering iron, how to set it up. And then, as we mentioned last time, the soldering iron can get very hot. And so we want to make sure that everybody is being very safe when they're soldering, and being very aware of where their hands are at in relation to the hot soldering iron. So please go back and understand how to properly set that up before you get started here today. So if you pull this out or look at it on your computer, you can see now that, first off, there's a little bit more of the history of that circuit, as well as a theory of operation that Josh went over earlier. But if you missed something and want to take a look at it again, that's a great place to start. And then, of course, we have our blank board here that we'll be working with today. So there's a picture of that. And then also important is the, put your safety glasses on, which is what I'm going to be doing right now on page 12. So the first thing you see here is that we have R1. It's 100K. We've identified R1. This is it here. And then we also need to identify where R1 is physically located on the board. And what we call the silk screen is the white writing and the outlines that you see on the top. So that is the very top of the board. You'll often hear it called the silk screen. Sometimes you'll hear it called the overlay. And then you also can see that there are traces on the top of the board that are connecting the different components. So if you really look,
move it forward just a little bit.
Thank you. So if you take a look, you can see that there are sort of these, what we call traces on the board, but imagine them as little wires that are touching these different, what we call the pads.
In fact, they are actually very close to being just straight up wires. They're actually copper traces that are laid between those components.
Yes, yes. And so when I look at this, this is called, well, typically you'll have a 2-layer board. Somebody has labeled here that this is the top layer. And then you also have the bottom layer. And so notice that on this particular board, there isn't a silk screen or anything on the bottom, but oftentimes you will find boards that do have the silk screen layer. But you can see that there are traces that are also wired on the back side or laid out. We also call traces laid out on a PCB. So again, we're looking for R1. And hold on one second. So what you want to do is start with finding what the component is. So R1 is located here. And I'm going to go ahead and take R1 out. And I'm going to also turn my soldering iron on. And I'm going to use a pair of pliers, or we can use this component part here. So I'm going to bend it, but if you don't have one of these devices, you can use your hands, of course, or you can use a plier, which also works to bend the part as well. Okay. Okay, so I have put the component in, and if you remember last time, we typically will come around and you flip it, and then you just have the component pushed out a little bit, and this holds it in place. So when I flip it on this side, I can see my component, the resistor is flat. So I am going to use a vise to do this. Josh mentioned the helping hands that he likes to use, which is also a vise. This is a different one that you can buy in order to do this, and it's just going to help it for me to be able to explain it with you. But it also helps to hold the board, so it's really nice to have if you can get one. Okay, so I have my soldering iron on, and it's up to 650 degrees right now, and I'm cleaning it. As we discussed last time, I have the sponge. It is wet. And then if you have the copper braid, you can clean it with that as well. But I typically just use the sponge. Yeah, here's also, you can use this to clean it off. So it should be very clean. The tip should be clean. Alrighty, so the first thing I do is I am going to heat up the point between the pad that is on the printed circuit board and the lead itself.
It's important that you do want to touch both of the surfaces at the same time so they heat up at the same time. If you heat up just the lead, the solder will tend to click to attach just to the lead itself, and that leads to a cold solder joint, which will fail eventually whenever the the natural temperature fluctuations happen. So whenever it gets cold, the solder itself will shrink a bit, and then you will no longer have a contact with your pad.
Yes. So you can see, I saw that, you know, once I started adding the solder is what we call where it starts flowing, and you'll see it get kind of bright. And then, you know, I just left it on there for a little while, and then I did the second one. And now I'm going to clip the leads. So this is why the safety glasses are important whenever you are soldering, not only to not get solder in your eye, but also to be able to clip these. And it just flew away somewhere, so that's why I'm wearing this. Also, if you have the board in your hand and not in a vise, typically what I like to do is kind of solder multiple components, and then I take the board and I hold it away from me. So, and then I clip away from my eyes. So I typically hold it away kind of towards the ground, and then I clip, and that protects me from getting hit by the lead.
It's also important that you pick up any leads that fall within your workstation. Again, these can cause accidental shorts very easily if you're not paying attention.
And notice how long that I am keeping the soldering iron on the parts. Oftentimes when you begin, when you're just beginning to solder, people have a tendency to not kind of leave the iron on long enough in order to get the solder to flow. So, you know, don't, you know, kind of, you touch the iron to the component and the lead, then feed the solder, remove the solder, and then remove the soldering iron. So next I will move to the capacitors. So I'll work with C2, since, well, we'll start with the 0.1 microfarads. So C3, I'm going to go find that one.
You should have 4 0.1 microfarad capacitors, as you should have noticed whenever you did your inventory.
All right. So I'm looking here. Here it is.
Now, these are ceramic capacitors, and they are not polarized. Right. So you do not have to pay attention too much to which side goes where, as long as they fit in.
Yep.
Now, as we mentioned in one of the previous lectures, the capacitors are more sensitive to mechanical strain. So as you try to stretch the leads apart, they may, you don't want to stretch them too far apart, or you may damage the capacitor itself. But you do want to spread them apart just slightly so that it remains within the board so that you're able to solder the capacitor.
And for these kind, you know, they're typically part of the capacitor sticking out, so you can support it underneath. Sometimes I support it with my finger holding on underneath to that component if I need to. All right, so in this case, this one is, as Josh mentioned, like a little less secure. So I'm going to just start with one of these, and then I'm going to take a look at it. So, all right, so I've got it on there. Same concept as before.
The goal is to get a nice Hershey kiss with the solder, and it should be shiny and smooth. If it should also not go jet, like you should not have like a spire of solder coming out of the pad. That's generally a sign of too much solder.
So there we have what that looks like. And then here's this again, the back side. And again, I'm going to point this away from me and go ahead and cut. By the way, in case we didn't mention it, these are called diagonals. This particular one is a little bit old, but there's kind of a flush side and then a side that's more open. So you definitely want to take the flush side of these, and that's what I'm using to cut these. Okay. All right, so that's how you do that capacitor. That is going to be the same for C3 through C7. Those are all the 0.1 microfarad capacitors. And then the same footprint and style is going to be true for C2 and C5, but with a different capacitance,
right?
Which is 0.047 microfarads. Or you can also say these terms. Sometimes people will say it in nanofarads, right? So C3, they would be, the C3 through C7 is 100 nanofarads, and then these are 47 nanofarads. So just know that, and it's, whenever you pick up a package that has capacitors in it, it may be marked either way. So just be aware of how that is. So I am going to go to C1 now, which is the 10 microfarad. So, where's it? Sorry. Goodness.
So C1 is an electrolytic capacitor. This is a polarized capacitor. So the orientation matters for how you install it onto the board. If you put it in backwards, you could have catastrophic results and completely destroy your capacitor. Fortunately, there is a nice little marker on the board to tell you which side goes where.
All right. Yes, and it's very clear in the manual too. So make sure you read the, as you're assembling, definitely read all of the different text and everything that's in the manual, because it's really helpful. So as it mentions, it is polarized, and it specifically tells you on here that the longer lead is the positive lead. Okay, but fortunately this capacitor also gives you a second hint, which is this the dark band, which I would say that's the gray band.
Yeah, the gray band.
It's the gray band. In the manual it says dark band, but it's actually this gray band is the negative lead as well, which corresponds to the shorter lead, so that makes sense. So sometimes these components will have two indications. One of them will be in the lead, and then you might have a marking on the component, and in this case there's both of these. Okay.
In some cases you may also have a plus or a minus on the capacitor casing itself.
Yeah.
Again, as we mentioned in one of the previous lectures, unfortunately manufacturers do not have a consistent marking for capacitors. This also includes on how they denote which ones are their positive and your negative leads.
Okay, and I'm just going to show real quick our schematic so that way we can find C1 on here, because I want to make sure you understand the difference between these two. So if you look, C6 was part of that group of the 0.1 microfarad capacitors, and you can see that it's just these two bars here. For C1, we can see that it's 10 microfarad. Also, there is a plus sign, and normally you'll just see the plus sign but not the negative, and we can see that one side is connected to ground. So that's what it looks like if you see it on the schematic. And now I need to find C1 here.
It's a bit out of frame.
Yeah, thank you. It's right here, C1. Okay, and on the board, we can see that somebody did a great job of referencing the plus side of it by this plus sign that's on the silkscreen layer.
Unfortunately, it does look a bit, it does kind of blend in a bit with the circle around there.
Yeah.
And if you're designing your own board, I recommend that you put the plus sign just slightly out there so that the silk screen is clear on where the plus sign is.
Yeah, if you're doing a board design, always helpful. Okay, so just real quick, because I'm going to double check myself, because these are the kind of times whenever we make mistakes. The plus is over here. I have the longer lead in the plus side. Then there is this gray bar that's indicating negative, and sure enough, it is in the opposite pad or hole that from the positive side, and it is in fact the short lead. So just to show you there how that looks. All right. So same concept, I'm going to bend them a little bit and to secure it, and then I'm going to come in, let me know, nope, I need to go out. By the way, every time I go to solder a new component, I'm cleaning the soldering iron. So it just becomes like a natural habit for me to do it, and I make sure, and every time I look at the tip right before I'm about to solder.
If you have large amounts of solder still on your tip, that can cause problems wherever you will inevitably add too much solder to a particular solder joint. And you will, especially if you're ever doing surface mount components, which you will again next semester, it's more likely that you will create a solder bridge between two surface mount pads.
All right, so I have that on here. Then I'm flipping it over, just taking a look at it. It looks like it's pretty secure. It looks good. So again, I'm going to cut away from me.
You're a little out.
Okay, thank you. All right, it looks good. Okay, so next is the semiconductor section. So or what I often call just the integrated circuit, IC. You'll kind of hear all of those names. So there's there's a couple different things here. Oh, I see. Some of these are.
Yeah, it also includes transistors and diodes.
Yeah. So I see that now. Anyway, there's several components we're about to work on, and so I'll kind of go through them. Yeah. The first one is going to be Q1.
Which most of these semiconductor devices, with the exception of the diodes, will be on your black phone. There are two transistors that should be on the black phone, and each of them have a part number written on the flat side. And you should read them carefully because they are different transistors.
All right, so I just wanted to show that those are different. And so I am going to this is what I want. Go back.
The two transistors are a 2N3904 transistor, and then there should be a J109 transistor. There might also, in some cases, if you have an older SkeeterSat manual, there might be an MPF102 transistor instead of a J109. Those are equivalent transistors. The MPF102 is just an obsolete transistor that we had to replace.
All right. So we can see here that the Q1, this is our transistor, is the 2N3904, which is what I am verifying for the third time in my hand.
This particular transistor, Q1, is responsible for the frequent, it actually in this circuit acts as a switch that turns on the second timer. And it actually is part of how you are able to get the difference between beeps that are commanded by the photoresistor. So the photoresistor just changes changes the frequency at which that Q1 turns on and off. That allows the speaker to beep.
All right. And I'm locating Q1.
Now, also a reminder that transistors and most other semiconductor devices are polarized. So it does matter the orientation that you put them in. If you actually look here on the schematic in the bottom left corner, there is a small diagram that shows you which pins are which. They are commonly known as the emitter base collector or the source gate drain, depending on what type of transistor you have.
Right. And just to, so go ahead.
And on the actual board itself, you'll notice that where the transistors are to be installed, they are not a uniform square. You'll actually see a little bulge where they are, and that helps you also as an indicator of where the transistor should be. So if you look at your transistors in your hand, they have a little bump on them. The bump should align with the bump, and the flat side should align with the flat side of the silk screen.
Right. So I found Q1. It was a little tough to see where it was at. So we have Q2 here, and then Q1. Unfortunately the part number is a little bit hidden on the silk screen, but it is right here. So Q1.
Scoot it over a bit to the left.
Yeah. So Q1 is here, and then Q2 is here. So as Josh was saying, I want to put these in. So if we just notice looking at this, it looks like the leads are pretty tight here. So you do have to typically spread them just a little bit. Again, you want to be real careful with how much you do this, but it does look like I need to spread them a little bit. So.
One of the things I would recommend in this case, because this is a semiconductor device, before you handle it with your fingers, just touch the table itself. Just make sure that you're grounded and that you don't accidentally create a static shock to the transistor. Most of these transistors shouldn't be terribly sensitive to ESD damage, but it's always good to be safe.
Could you show the side angle, please, so I can see the piece?
Is this the angle you? Yeah. And the same thing here is on the back. I kind of spread it apart, but you'll notice because this is spread out, we can't just push it in all the way. It's going to have to stick up a little bit. So that's all right. All right.
When it comes to transistors, what I always recommend is solder a single pin in, then double check your orientation, make sure it's in the correct spot, and then solder the rest of the pins in.
Yeah.
Again, these are polarized. Putting them in the wrong way will mean that your board will not work.
So, can you see this?
Let me do this. Go.
So I'm going to solder the one pin. I'm going to check it again. It looks good. It's not crooked or anything either. So, all right.
With devices that have more than 2 terminals, 3 terminal, 4 terminal, I often highly encourage soldering one pin and then checking the orientation, making sure everything is flush before soldering the rest. As I demonstrated in the soldering activity last time, it can be very difficult to remove multi-terminal devices from the board. And again, she is making sure that the leads are away from her as she flips it, just in case that whenever they shoot off, that they don't hit her eyes or hit anyone in particular. She is wearing safety goggles to also protect her eyes during this.
So the next one is the diode. And this is the one Josh pointed out earlier that might be taped to your sheet.
It should be.
Yeah, it's the one in 4001. So let me just take a look real quick at the schematic so we can take a look at what it looks like again. It is up here. Yep. So D1.
This is a rectifier diode. The purpose of this diode is to protect this board from if you put the battery in backwards.
And remember, we talked about how this device acts like a gate. So whenever it's in this orientation, if there's a more positive voltage coming in, then it will allow the current to flow through. And last time we talked about these will also have a 0.7, typically around, it depends what type of diode it is, but this particular one I can tell you is around 0.7 volt drop. That's going to be across that diode. If you put the battery in backwards, then now you would have the ground and the plus would be swapped. So therefore, this would act like a gate and no current could flow through the circuit. Okay.
Your diode's right there.
Oh, thank you. Okay, so let's just Josh pointed this out earlier, but we're going to take a look at it. So this is a polarized device again, so it's really important to pay attention to it. So as we showed here, there's this negative, sort of this bar that comes across to me. It looks like a negative sign, and that corresponds to this gray bar that's across one side of this device. So that is the negative side. And again, this is stated all into your assembly manual too. So if you miss some of these orientation things, don't worry about it. You can just read about it. All right. So when we look for D1 here, CD2, all right, here it is right here.
You'll notice that on the silk screen, it actually tries to mimic that same bar notation that you see on the diode itself.
Yep.
That is its polarity marker for this.
Yep.
There is no plus or minus sign in this case. Sometimes you will also see on the silk screen an actual diode symbol. But it depends entirely on the board and whoever made the board on what notation they do.
Hopefully they have something.
Hopefully they have something.
Otherwise, you'll have to go back to the schematic and then use your multimeter to ring the circuit out or check continuity. Okay, so same concept here as the resistors. So I just did this, but I'm going to check one more time and make sure I got this right. Yeah, it does. I do see it. Okay, awesome. And these leads are a little bit thicker than the resistor, so you just have to heat it up maybe a little bit longer, or use a little more solder.
Yeah, thicker leads will require more heat to heat up, just because of the sheer amount of material. This is also true, by the way, for cables as well, for wires. If you have a thick wire, it will take you longer to heat up that wire as opposed to a thin wire. Again, she is pointing it away from herself so that those leads do not ricochet or hit her.
All right, next is D2, which is also a diode, but it's our LED. So this one looks like a little light bulb, and it will emit light, so that's why it looks like that. So I'm just gonna, these typically can be a little difficult to, these are also polarized. And so I believe that the longer lead here is the positive side. Yeah, and he mentions, whoever made the manual on D1 says the longer lead will be the positive anode end. So I just want to make sure that that's stated somewhere. So you can see that in the D1 side. So this means that this will be our positive lead, and then we have our negative lead. So here is D2 right here. And I can see that they've marked a pin 1, but I don't see the positive sign on that.
Yeah, so for this particular diode, this is a case whenever the silk screen isn't very descriptive on what orientation it should be. There are a couple of ways you can figure this out. One is by paying attention to your schematic in your diagram. So if you look on here where the LED is, one second as we adjust.
Here it is. I found it.
It's right there. And so if you pay attention to where it's connected, you can see on one end, on the positive end, if I'm correct on that, it is connected to R3. So if you look at the last page of your manual, or on the board itself, you can actually see that there is this kind of complicated diagram here. This is this is the actual board layout of it. All the red traces that you see are the ones that are on the top of the board. All the blue lines are the traces that are on the bottom. So if you look at R3, you can actually follow it, and you can see where it connects to the diode, and you can verify that, okay, that's where that connects. You can also see on here that the silk screen actually also has a flat end on the other side to help indicate the negative side of the diode. But unfortunately, in this case, and this is true in many electronics, the silk screen may not always be super descriptive.
And a second way to do it, can you hand me that meter? If you, for whatever reason, you don't have the layout in front of you, you can also use your meter. And so we looked at the schematic, and we knew that D3 somehow connected to R3. I mean, D2 connects to R3. Okay, so on here, we have it on this diode check. And so when I put the two leads together, we can see that it's reading out, I guess that's resistance.
Yeah, I believe it's resistance.
Okay.
So this is what is often known as the continuity check. You'll see many multimeters will have this kind of symbol on there or something similar. Nicer, more expensive multimeters, whenever you touch them like this, will actually make a loud beeping noise to indicate that there is a electrical short between the two leads.
Yeah, and you can also just put it on the 200 and use it as well to measure the resistance between 2 points. So you can see here that I'm holding the leads across. We expect a short, and it looks like, yeah, it's pretty close to a short right there. So I'm going to go back to R3.
Pay attention to your head.
Yeah, sorry. So, so again, I'm just checking that, and I'm seeing if, okay, it does look like that's a short, but then is this one a short? No, this one is our open. And then just for fun, that this we would expect that there would be a resistance across, but it's the wrong range. So probably if I went to the
R3 is a 470 ohm resistor.
Okay, so I've got it at the, that's about right. I've got it at this, which setting is a 20K setting.
Yeah.
Then we can see that that makes sense with what we're reading here.
So those are some steps that, if in the case of a poor silk screen, or if you're uncertain with how something should connect, some ways of verifying how it should connect before you solder in the component.
Yeah. Okay, so we've figured out now that the square one is the positive, and then the circle is the negative side. And then we also read the manual and found out that the longer lead is the longer lead is the positive, and then this is the negative.
Now, another interesting thing with particularly with LEDs is some manufacturers will actually create one side of the LED that will be somewhat flat, as opposed to the other, as an additional indication of which side is the positive and which side is the negative. It usually will be on the case itself, but again, this is also similar to the capacitor case, where there's not necessarily a uniform manufacturer policy behind it, and so your mileage may vary.
All right.
The next component we're going to solder in is the IC socket. Note that I'm saying the socket, not the IC itself.
Not this.
Yeah, so the reason why we do this, particularly with through-hole components, is if we solder that IC down directly, it will work perfectly fine. It will be, you can do that. But say something happens to that IC and it gets damaged and you want to replace it. If you recall from the last from the soldering practice, whenever I tried to remove the multi-pin IC, it's difficult, and you might not even be able to salvage that IC at all. So to avoid that, for through holes components, we have IC sockets. Now the socket itself is not polarized, but there is an indication on there for you to follow. There is a little notch at the top that should line up with the notch that is on the board itself. This is to assist you in making sure that the chip itself, whenever it's soldered down, is inserted in the correct way.
So I'm going to check this again. Yes, the notch is correct. Okay. And just real quick before I solder this, let's see. They have pin 1 indicated right here with a circle, which is on the silk screen. So it is good to have the notch line up here. And then sometimes you will see that pin 1 will also be indicated with a square pad rather than a circle. So just be aware if something happens, the way to, some boards have that. This particular board, it looks like all of these are circle pads with the pin 1 on the silk screen. So once you put this on, you might not be able to see this, but you can if you go to the last page of the manual, and then you would be able to know the orientation compared to all the other components. Okay, so this is this is where things can go wrong with soldering, mainly being able to solder something very flat again.
Yeah.
So this is often when you find components that are will be hanging off like this or something. Electrically, when that happens, if the solder is touching the component and the pad, it will work electrically, but it's really not ideal to have, you want all these components to be flat on the board.
Right.
So, go ahead.
One of the other issues that you will most likely find while putting in this component is it doesn't want to stay in while you are soldering, especially if you're having it dangle in the air like Jill has here.
Yeah.
There are a couple of ways you can resolve this. My favorite, in the way that I typically do it, honestly, is I just get a piece of paper or something thick and support it underneath. Or you can use your finger and solder a single pad on there, then verify that everything is aligned, then solder a second pad to make sure that it's flush with the board.
And that's the method I'm going to go with right now. So this is one of those times whenever you're using your pinky or some other finger to hold it that you need to be aware of where that pinky or finger or whatever it is, whatever part of your hand is supporting this and where you're going to put the soldering iron. So if I am going to be soldering one of these pins up here, I need to make sure that my hand is supporting it from the back of the chip. Because once I put the soldering iron to this pin, it's going to heat up and that heat can transfer through to the other side wherever your finger is. So just be aware. So I'm going to start by soldering the very top. Oh, by the way, I do see that pin 1 here, it is a square on the bottom, so it looks weird on the top, but it does, you can see right here that it is. So what I tend to do, I can do it actually. So you kind of can get pretty creative with how you use your hands, because now we need to hold the solder, and we need to hold the part, and we need to hold the part flat too, and I need to put the soldering iron here. But I have right now my pinky under the board holding the back end of the part, and I've got the solder with my regular hand, and then I'm going to feed this through.
Sometimes you may just need a helping hand.
Yes. Okay, so I'm only going to do one pin. This is really important, and I'm going to continue to hold the back side for a few seconds after to make sure the solder has cooled. If you pull your finger off right initially, it's just going to fall through the board or it's going to become lopsided. So it's been several seconds now, so I believe it's in there. So let me see if I've got it flat against here. And it looks pretty good to me. So if I flipped it over and then I said, oh, see, I didn't get it in flat all the way, then I would put it back on and then I would redo that one pin and try to, and you know, at that point you already have the solder on, so you just need to heat it and then push it in properly.
Right.
So, okay, and I look at the pin, it looks pretty good. I feel like I could heat it back up again a little bit, but it looks pretty good. Okay, so now I'm gonna stay away from that pin because I don't want it to get hot and then for the part to slip through, right? So I typically tend to start to do the second pin at the opposite side. Again, cleaning my soldering iron after every time I start to solder again. So now I don't have to use my pinky. It should be pretty solid in there. I think it's pretty solid. So I'm going to do the opposite pin. See, it's for whatever reason taking a little while to heat up. I'm not sure. Okay, here we go. So on there. So I'm going to go ahead and put my hand back under the front side where the previous one, and I'm just going to push it one more time, and then I'm going to go ahead and let it dry. That way I can make sure I'm getting it flat. So after I do this and I start soldering pins, again, it's very difficult to remove. So I do this every time. I do the first pin, I check it. I do the second pin across, I go back and I check it one more time. Okay, looks good to me. So if something doesn't look right on that pad, you see that oftentimes I will go back and by the way, I'm cleaning my soldering iron right now because I see solder building up. But I go back and touch up, you know, so you don't have to, you know, if you see it doesn't look like it flowed very well, you can kind of go back and touch up some of those pins.
There is no shame in touching up your own soldering. In fact, that's actually how often I often get good solder joints is often I will make a bad solder joint, look back, that doesn't quite look right, and then I'll go touch it up again.
Yeah.
It all comes down to having a good observational eye and being able to identify whenever there is a bad solder joint. One of the things that I always look for, especially when examining student work, is I'll pay attention to the solder tip, the solder itself. I'll hold it like level to my eye, and I will look at how the solder connects to the pad itself. If you have a cold solder joint, you'll actually see the edges of the solder will pull away from the tip, like from the pad itself. And that's how I know, okay, you should go back and touch that up with a bit more heat. You should put the soldering iron to it a little bit more so that it flows to the pad. That is a classic case of a cold solder joint. And the more often you do it, the more often you examine it, the easier it is to identify these things. It just takes practice.
And I haven't soldered boards in a while, so that's why you see me being extra careful here. So when I'm, you know, doing a board, soldering a board for the first time, looking at components, I go very slow. But then at some point, if you have to make a batch of boards, then you will become faster. But it's best just to go very slow. I mean, you can see just how slow we're going and examining and rechecking things. So it looks pretty good. I don't see anything weird. Any of those, the bad solder joints we talked about, everything looks pretty good so far. Okay, awesome. And on top of that, everything is flat on this side of the board. So by the way, the chip here, this socket is still a little hot, so just be careful with your hands. Okay.
Sometimes whenever you are soldering components, this is especially true with surface mount components, you should pay attention to how long you heat the soldering iron to the component itself. Some components can be damaged by too much heat. The details of this are often included in the data sheet on how long and how much heat a component can have.
All right, so next we're going to do J1 connector, which is what we call a header connector. And that's just because it's a bare connector where it just has these pins coming out. There's a lot of different types of connectors, so this is the one we're doing here.
Yeah. Now there is one issue with this board. You'll notice that up top there is something labeled J1. The connector that we distributed is actually the thermistor connector down at the bottom. That is just a misprint with the packing list.
Yeah, good point. Okay, so this is another time with these open headers like this that are where you got to be really careful with where your fingers are at. Because again, you need to solder the pins, but then you've also got your finger nearby. So let me try to turn this sideways to show you where I'm going to hold. So this is really where I'm holding, and then I'm going to actually solder this pin right here. So
generally not a good idea to put your finger on the exact lead that you're soldering. It will get very hot. Metal is a good conductor of heat.
Is this one fuller?
It's not. This is not. This particular, these kind of bare So some connectors are polarized. This particular one is not.
These are what are known as breakaway headers.
But there is a pin 1 on the back. You can tell if it's not obvious on the front by the square pin. So, and then you'll see the other 2 are circles. So I'm going to come in, again, being creative. I've got my finger on the very first pin on pin 1, and I'm going to solder pin 3. And I'm putting pressure on it to make sure it's flat. So I'm not going to solder all of them. I'm going to just solder this one. And then I'm going to check it on the front, because this is also one of those that's really easy to get it twisted. And then you see I'm letting it cool before I'm going to move on. Okay. So I'm checking it, and I don't know if it's obvious to you, but it is crooked here. It's kind of hard to tell, but you can see it a little bit. So I need to make it straight. So to do that,
One second. Okay.
so I'm going to reheat that pin and make it straight. And then I'm just going to hold it and let it cool off. Okay, then I'm going to check it again. I think it's good. It could probably be a little bit more, actually. And a quick note, on this board, I think it's fine, but whenever you are starting a board, it's always good to look at the components and when you're first starting to solder, and solder all of the lowest profile components first. So basically all of the resistors, maybe that diode would go first, and then you might move up to the capacitors and the LED, but then you might get to some of these, the higher components, the connectors and the transistors and things like that. So just, it helps with your placement of your hand, of where you're going to be soldering at, as well as if you don't have the vise, you can put this flat against the table. But you got to be careful of that capacitor and different things that could potentially bend on the back side of the board. So just while you're soldering, so be really aware of how do you have the board mounted, or and the different components that could be damaged as you're moving the board around. Okay, so I'm gonna go ahead and do this, the speaker. Before doing, just as I mentioned, I'm gonna wait to do the battery holder, even though it's in line here, until I have everything else kind of done. So I can see on here that it is polarized, and this is what the speaker looks like. So fortunately, there is a plus indicator on the speaker itself right here, and then there's also a plus indicator. Oh, sorry guys.
I'm also just answering a question real quick.
Yeah, sorry. Okay, sorry about that. This is the speaker, what it looks like right here, and then there's a plus sign here, and then there's also a plus sign on the board itself. So these will mate up. So it should be like that. I'm not sure how this speaker gets hot or what properties are going to happen whenever I solder the pin, but I'm still going to just go ahead and hold this side away from the pin 1. I'm going to solder pin 1 right now, and I'm just going to hold it away from that side, just because I'm not sure. I've never soldered a speaker like this before. But I don't want my finger to get hot.
Can you adjust the camera, please? Thank you.
Sorry about that. All right, so what I was just saying is you can see that my finger is holding on this pin, and then I just soldered this pin right here. Okay. And
You
that's,
noticed right there,
yeah.
whenever she started letting go of the speaker, the pins themselves both jiggle despite there being solder on them.
Yeah.
That is a classic case of why why she's holding it down and pinning it to the board.
Yeah.
That solder takes a moment to dry, to solidify. And if she had just let go, that component would have just fallen out the board and landed up on the table below.
Yep. So like right now, like I would like to go back and touch up pin 1, but I'm not going to do it. I know the board, actually, let me check it real quick just to make sure I've got it flat here. It's flat. Okay, awesome. So now I can go ahead and solder the second pin, and then I can touch up the first after the solder is cooled on that second pin. So I'm going to let this cool here. And then I would like to just add a little bit more solder to this one. Okay. Great. There we go. All right. So the thermistor, we would like to show you how to do that on Thursday.
It's a little bit more involved.
Yeah.
For your reference, the thermistor is found on the index card that is inside of the SkeeterSat.
Oh. Yeah.
Now, one quick thing I will note here: there are 2 thermistors that are provided to you. They are slightly different resistances. You are free to pick which one you like. Some of you might have a blue thermistor. Some of you may have a red thermistor. They're all fine. Whichever one you want to use. The main issue with this is we have to actually solder these to an additional wire, and we're running a bit short on time here, so we're going to just handle that next time on Thursday. Another thing to note here, there are also 2 photoresistors provided here. And it is also a similar case here where they are different resistances, but you can use either one, whichever one you feel like. If you want to have a nice big surface area for your photoresistor, go with the big one. If you want the small one, go with the small one. There will be a slight change to your SkeeterSat and how often it beeps and the pitch that it gives out for the thermistor, depending on which pair that you pick. But the board will function all the same regardless of which ones you pick.
Do you want to heat this up?
Hmm?
You wouldn't heat this up, right?
For this, you don't have to, but afterwards you can run it over with a heat gun.
Okay, so I'm going to choose the larger photo resistor. So these are not polarized, so just be aware of that. And then it's called this LS1 right here is what we're going to be doing. It would make a really cool ring. Anyway, so there's something that you can do to maybe help out is there's a recommendation for heat shrink or plastic insulation. So this is what heat shrink looks like. Normally, there's a heat gun that you can use in order to heat up this material, and you put it over different types of wires or anything open, and it insulates it.
Out of frame.
Thank you. So for this particular case, I would recommend not using your diagonals, which is what I've done, because if you want to cut off little strips of heat shrink, because it makes it not even. So I would use like a regular pair of scissors for that. But you can put these on here to help.
Out of frame.
Yeah, thank you. So put the heat shrink on, and then just kind of help. Yeah, go ahead, Josh.
Yeah, so what this heat shrink does here is it actually makes sure that the photoresistor is elevated on the board, which can actually make it easier to solder.
Yeah.
They actually don't provide all that much function to it by itself. It's mostly just so that you can elevate it and keep it away from the board and be able to potentially just flip it over flat on the table and solder the two components, the two leads.
Wait, do we have heat shrink?
I don't. It is not provided in the kits. That is something that you may ask your professor for.
I can do it without it. Let's just see what
it is
it's.
not required. It's
Yeah.
an optional thing that just can assist.
Let me just do it without it so we can think about it here with how you're doing it right now, if you guys are following along. So what I would do if I wanted to keep this elevated off the board a little bit is I would just go ahead and pull it off and then bend the leads. Okay, so now it should be pretty stable. So you can do this as well. And is there an optimal height that they need for this, or is it just kind of?
There's no specific height that's required.
Okay, looks like just 5 or 6 millimeters or something like that would be great. Okay, so it's pretty stable like this, so let's just go with it. I'm coming back into view. Here we are. If you can hear me, I'm cleaning my soldering iron again, so please do it.
I did the wrong thing.
Oh no. Hold on. Oh, you can still see. Okay, cool. All right. So let's see how I did. That looks pretty good. Yeah. And it definitely gets hot when you solder it. So I did notice, because I was able to bend the leads, I did not hold the component. Touch back on. So even after I cut the leads, it's like, oh, that doesn't quite look right. I still go back and touch them up if I need to. Okay. All right. So we have all of that. I think the last major component is the battery. It's just right here. Okay. So here's the battery holder. This can only go in one way, so that makes it easy. And then it looks like they've got some other nice little holes that match up here.
Yeah. You'll notice that on that still taped to your inventory list are 3 nuts and bolts.
Oh.
And they happen to line up very nicely with the 3 holes that are on the back of here. This is actually how we're going to make sure that the entirety of the battery holder remains steady, flat against the board. But first, we have to solder. We have to make sure that we have to put in the leads and solder the leads down.
So for this one, I'm just gonna.
Yeah, you do want to make sure that the holes do line up with the holes within the battery pack itself.
Yeah. I'm gonna go for my vise here. Things start getting complicated. Try to go to the vise, but you can accomplish this. Okay, I can not see.
Little north. Bit out of it.
Okay, I'm gonna go ahead and take one of the screws. I wonder if I can. These are pretty small, actually, so it might not be very helpful.
So in this case, Jill actually just opted to go and grab a screw
Yeah.
and one of the bolts to actually help keep it flush against the board so that it's a bit easier to solder.
Yeah. And now I know it's lined up because it was really difficult for me with the document camera to be able to line it up. So now, okay, the other holes look pretty good. They're pretty close. Okay, so this is one of those again where I'm gonna have to support it from underneath. Fortunately, you can pretty much support or anywhere on there without well, there are metal components underneath. I'm sorry, so you definitely don't want to touch those. You want to make sure you touch the plastic part of this. So I'm just going to get it ready.
So what I would recommend in this particular case is solder one of the pins down, then go and install all your screws to make sure that it is flat on the board, and then go and solder the other component just so that you know that the board is flush and that you remove the possibility of it just falling out of the board. Additionally, if they're not aligned because you only have one pin solder, you can go back and touch that, hold the soldering iron to that one pin, and then maneuver the battery holder a little bit so that the holes line up.
And these holes are bigger as well as so just notice I kind of held the soldering iron there a little bit longer before feeding in the solder to it. So, all right, so let's check this and make sure. I'm going to hold my screw, make sure. So it looks good. It looks like I've lined up all the holes okay. Soldering that other one? Yeah, good. Yeah. Which way do they go? They go the other way. Does it go from the inside out? Yeah, that's go on the back side.
Yeah. And just so that you're aware with the orientation with the bolts, the head of the bolt goes on the inside of the battery holder, and the nuts attach to the bottom of the board. They are very small nuts.
Yeah.
So you, do your best to tighten them. They're mostly there for keeping the connector from moving around.
Yeah, you might need to get a socket wrench to tighten these up. Or
alternatively, you can use a pair of pliers and then just try to manually turn it there. I gotta find your best way of just tightening the bolts.
Yeah, this seems like it's working all right, actually. And righty-tighty, lefty-loosey for those who to always remember how to tighten.
Now, we are coming close up to the 8 p.m. cutoff for today's lesson, but we will be here on Thursday to finish up any of the last little details with this, and we will be here for the entire 2 hours on Thursday to answer any questions as you guys go through and assemble the SkeeterSat if you have any issues.
So you're saying Thursday is just kind of continuing this?
Yes, Thursday will be more continuing of this. It'll be more of it probably won't be doing any recordings and stuff like that. We'll be just mostly here answering any questions should you need some help.
We do have to do the thermistor.
Yeah, we will
Yeah.
be teaching you how to solder together the thermistor
And then checking the resistance. Is
and
that
checking
it?
the resistance. There are a few little small tests that we have
Yeah.
to do. My small correction there. I know.
Yeah. Okay. So I think those are the main points that we're going to cover tonight. Yay. Hopefully this was helpful for you guys.
Now I'm going to go ahead and stop the recording here, and I know that Charles had a question regarding his whole one of his connectors, so we're going to go and deal with that now.